Okay, a math statement that contains symbols and expressions. Well, it could just be called expression. But another way they're described is an open sentence. Can you read that? Maybe not anymore. I'm writing it again. A math statement that contains symbols and expressions is an open sentence. A sentence that contains an equal sign, now that's what? Equation. That's the one you guys were able to come up with. A blank is the set of elements that make an equation true. Solution set. So today I'm going to give you an equation and then give you a solution, like a list of possible solutions, and you're going to plug those in and see which ones will make the equation true. There's usually only one. So a solution set with equations usually just contains one real number, sometimes more. Three more. Little fraction work. Fraction practice. Okay, so show your work. No decimals. So I want to make a common denominator. We've talked about this already. It's nice just to have both numbers or all the numbers. If you're dealing with a fraction, all of them be a fraction. So I put a 1 under here. I'm going to draw an arrow. The common denominator will be 4. So I want both fractions to have 4 down below. Libby, what should I do? Yep. Yeah, because I multiplied the bottom by 4, so I'll multiply the top by 4. It would be 12 on top. So then what's our final sum? Improper fraction. 13 over 4. Love it. That's the answer I'm looking for. Yep. All right, so what then is our common denominator in number 5? 6. So I'm going to write 6 plus sign 6. The first one doesn't change. What did we multiply the top and bottom for the second one? Add across the top. 8, 6. Is that full credit? We need to reduce it. If it can be reduced, you need to reduce. So The top and bottom both divide by 2, so I'm going to do that. And so the equivalent would be 4/3, and that's full credit. Still an improper fraction, but in its simplest form. Okay, let me pause for everybody to need a reminder. I really like it when it bitty boop boops in class. Mikhail, what's your common denominator on number 6? Does 3 go into 10? No, but good try. So this one's a little different. You're not just picking the biggest number. You got it, Mikhail. What number can both of those go into? Okay, Aiden? 30. Worst comes to worst, you just multiply them together. Okay, when it comes to fractions, if you can't figure out the lowest common denominator, you can just multiply these together, and that will give you a common denominator that'll get you to an answer. Keep my minus sign. So what do we multiply the first fraction by, top and bottom? 10. 3 times 10 is 30, so we have to also multiply the top by 10. The second one, we have to multiply by 3. 20 minus 3. 17/30, final answer. Okay, I have a handout for you. I think I have it here. There it is, this side. So head to the side that says equations. It is double-sided. In here, we're working on chapter 1-5, so if you're confused, that's the part of the book you want to look at. And the title is equations. So we want to solve equations with just one variable. Oh, and solve equations with more than one variable. We're solving using a replacement set. So they're going to give us suggested answers, and we're going to plug in to see if they're true. So show how to find the solution set of this equation if the replacement set is 2, 3, 4, 5, and 6. So we're going to test all of these numbers. Test all numbers. In the, I wrote the wrong word there. In the replacement set. In order to find a solution. And some of you guys are good with numbers, and you'll look at it, and without showing any work, you'll come up with the answer. But I want you to show work. It's more about the process here than just like figuring out the number. Just like the process of plugging in and testing numbers. So their table's been provided for you, but it won't always be. So we're going to test A here and see if this is a true or false sentence. And there really isn't enough work, so don't even love the table that's been provided. Let me show you what I mean. I'm going to do 4, because the equation's right here. I'm going to do 4 parentheses. I'm not going to write A. I'm going to put the 2 in. Plus 7 equals 23. We better go off to the side and do work. So you guys have a big white area here. Maybe do your work here. I'm going to go off to this side. This is my work area. You figure out where you want to do work. So is 4 times 2 plus 7 equals 23? Is this true? What's 14 plus 7? I'm at 8. Sorry. Nah. So does 15 equal 23? For your work, put a line through it. We can go ahead and say that's false. I'm gonna put a line here too, because I don't like false equations. I put a line through it. False. Alright, now plug 3 in. Show your work. Is 3 true or false? We got false again. I plugged it in. I ended up with 12 plus 7. I added 12 and 7 to get 19. Does 19 equal 23? False. Put a line through it. This time I'm going to replace A with 4. Does 4 work?
Yeah.
Alright, we found our answer. True. Well, that went really far from where I wanted it. So A does equal 4. That's true. All the other ones are false. Should we keep going? I really don't want to. There's only one true statement. Now, if this was an inequality symbol and not an equal sign, there would be lots of true statements. Okay, more than one true answer. With the equations like this, there's only one that's going to work. So I'm going to just go ahead and give you permission to stop there. You found your answer, you can stop. But show work until you find it. Okay? All right, let's head to A and B. Same concept, plug. Oh, is this the same concept? We're missing a replacement set. Are we supposed to use that?
No.
Has anyone gone ahead and used the same one? Do they work? Yeah. Alright, so I just filled these in. You'll be provided with the replacement set. So same replacement set. Take M out, put 2 in, and decide is it true or false. Alright, so 2 comes out false. Plug 3 in for M. And how'd 3 work out for you guys? True, that one is true. So now we can determine that M equals 3 because our statement came out true. So from the solution set, 3, or the replacement set, 3 belongs in the solution set. Okay, B looks a little more complicated, just a little bit longer. Any questions on letter A? Okay, should work over here this time. Is 28 equal to 4 times 1 plus 3 times 2? Is 28 equal to 4 times 1 plus 6? Is 28 equal to 4 times 7? Is 28 equal to 28? True, our first one works here. So now we know that D equals 2. Check your work. Does anybody have a question about letter B? So on a multiple choice test, you can use the same strategy. So the last 2 questions here, it says, I think, standardized test. So you'll take the PSAT next year, 10th grade. You can take it this year, a test called the PSAT. It's like the pre-SAT. It helps prepare you for the SAT. I think it costs you like $20 this year. If you want to take it, you can sign up and take it. In 10th grade, everybody takes it for free. Like the whole county or state, you'll take it no matter what at school. But today you can opt, or this year you can opt to take it if you want, which is a good idea because the more you take it, the better you get. So you take the PSAT optional this year, the PSAT required next year for free, and then you take the SAT, which is your college entrance exam, junior year, and that you, for the most part, I think you pay for. And then you take that and then you use that to get into college. So here you have standardized test prep, but I want to be honest with you, while this is good practice, most standardized tests don't give you these options to where you can just plug in and say is it true or false. But it's a good thing to be aware of on a standardized test. If the options are given, just plug in. Try to see which one works. Yes, and check. Yes?
What type of questions were the tests that we could take this year consist of? Like the class that we took this year?
Yeah, the PSAT goes through Algebra 1. There will be like a little bit of geometry on it, similar to like the perimeter question we did yesterday. In the, not on the quiz, but in the quiz review where you had to like take the expression out and plug in for L. I don't know if you remember that. So there'll be pre-algebra, algebra 1, and geometry on there. Anybody else have questions about standardized tests that you take in high school? All right, so let's plug in 3 plus 4, 2 to the third minus 2. First, I'll try 19. Does 19 work? 3 plus 4, 8 minus 2. I hear calculators. 3 plus 4 times 6 equal 19. Does 3 plus 24 equal 19? Does 27 equal 19? Oh, so I'm going to, 19 does not work. And then I'll head to letter B. 3 plus 4 times 2 to the third minus 2, does it equal 27? True. So we'll circle 27. When you plug 27 in for B, the sentence comes out true. All right, what'd you guys get for the T? Anybody find that answer yet? Yes, Joseph. 27. So everybody jump to 27 if you haven't yet. Group work. Try 27 first. 27 is the answer for both? Random. So does 27 equal 81 divided by 3? Does 27 equal 27? True. You can see some order of operations questions there. So this time we took this value out and tried these, but we jumped to the right answer just to save time. Okay, now I want to challenge you guys to try some with fractions. So you can do this in your notebooks. Let's see, I want you to try 8 and 9 on your own. Try some fraction problems. Try number 8 and 9 challenge questions. So start with this one. You're going to try plugging in the fractions here, and this is why we did a fraction warm-up. I really wanted to challenge you guys to do some fraction work. So these numbers in these brackets, this is the possible replacement set, and you're going to plug in for x to see which one is the solution. So try it now with fractions. So show your working fractions, get common denominators. Okay, so I'm going to try by testing out 5/9 first. Okay, so I'm going to take the x out and I'm going to put 5/9 in. And I'm going to say, is this true or false? Is this a good sentence? Or is it a contradiction? Contradiction, that's an English word, right? People contradict them. You're contradicting yourself, Mom. You told me to do this and then you told me to do that. What do you want me to do? So I'm going to come the row below and I'm going to make everything have a denominator of 9. Because when I look at those 3, I know that I could make 3 turn into 9 and then everything will have a denominator. So I will multiply that one top and bottom by 3. And now I can combine these. I can do 5 plus 6 is 11. And then I compare to see if my sentence is true. 5 plus 6 is 11/9, and 11/9 is not the same as 13/9, so I'll put a line through it. And this is a false sentence. So in the replacement set, 5/9 is no good. Put a line through it. You guys are telling me I should jump to 7/9? Okay, I'm going to jump to it. So now I'm going to test out 7/9. So is 7/9 plus 2/3 equal to 13/9? And I can hear you guys kind of saying, well, we already know what 2/3 is. So that's going to make the next one easier. 2/3, make that into a common denominator is 6/9. So good job picking up on that. Seven plus 6 is 13/9 equals 13/9. True sentence. So 7/9 equals x. So here on the problem, and I know you don't have the problem in front of you, I can circle that. That's the answer. Yes, yes. Feel free, take a picture of your fraction work, and then head to number 9. Go ahead and show your work for it. Head to number 9. If you're ready, head to 9. Try to give you some more time. Just so many fractions. It looks overwhelming. So some of y'all are catching on and you're looking before each test to see which one makes sense. Like, wait a minute, let's shorten this. Which one of these actually makes sense? So for number 9, I'm going to test out 2/3 first. So I'm going to take the x out and put this 2/3 in. 1/4 times 2/3. I'm going to make that 2, 2/1. And I'm going to get a common denominator and combine. How many of you guys distributed in? Okay, good. Distributing in kind of is more complicated. Okay, so now I'm going to go 1/4 plus 2/3, and I'm going to make a common denominator in the parentheses. So I want to be able to add this, so I'm going to turn 1 into 3 by multiplying it by 3, and turn 2 into 3. Now I have a 6 inside. So now I have 1/4, 2 plus 6 is 8. You just add across the top, so that's 8/3 now inside. We'll keep going. 1 times 8 is 8. This is now multiplication, and 4 times 3 is 12. So is 8/12 equal to 5/6? I think I'm going to reduce this. So that's the same as 4/6, and 4/6 does not equal 5/6. So 2/3 after all that work came out false. What do you think it is? But we can look now and see. Yeah, with 4/3, you know what the inside's gonna look like. I'm just gonna show the work. Raise your hand. Keep going. What time is it? Alright, I'm going to do 3/4 next. So now I'm going to put 3/4 in for x. 1/4 times 3/4 plus 2/1. Does that equal 5/6? 1/4 times 3/4. And here I want a common denominator. So I'll multiply the top and bottom by 4. Does that equal 5/6? Now that we have a common denominator, we can add the numerators to get 11/4. That equals 5/6. Multiply. Is 11/16 the same as 5/6? Nope, those are different. 11/16 is probably pretty comparable to 5/6. I bet 5/6 is more. But it's kind of hard to picture, right? Think about a pizza cut into 16ths. You got 5 of them. Or a pizza cut into 6, and you got 5 of them. How could we compare these fractions to know which one's larger? We could get a common denominator, or we could look at them in decimal form. Somebody in your calculator tell me which one of these is bigger. Is 11/16 or 5/6 bigger? Maybe? You think so? Okay. Who thinks 5/6 is bigger? Thumbs up in the room. Who thinks 11/16 is bigger? Almost nobody. Let's look at the decimals. What's 11/16, you guys? Okay, what was this one then? What's 11/16? Yeah. What's the decimal?
11 divided by 16.
11 divided by 16. Okay, now what's 5 divided by 6? Alright, so Libby, your guess is right, and everyone else who did a thumbs up. 5/6 is bigger. Alright, so we have 2 left to test. Who thinks we should test 5/4? Thumbs up. Who thinks we should test 4/3? Thumbs up. Okay, 4/3 is looking really promising. Alright, this will be the last thing we do, and then I'll let you guys start yours. Okay, let's test out 4/3. So we have 1/4 times 4/3 plus 2/1 equals 5/6. 1/4 times 4/3, and we want a common denominator. So we're going to multiply this top and bottom by 3 to get 6. 1/4 times 4 plus 6 is 10. 10/3 equals 5/6. Is that working? We'll multiply. 1 times 10 is 10. 4 times 3 is 12. Oh, this is a proportion. That's the word for that. Is 10/12 the same as 5/6? Yeah, we'll divide the top and bottom by 2 to reduce it. 5/6 equals 5/6. True statement. So it turns out, yeah, that does deserve a round of applause. X equals 4/3. That was a good fraction workout. When's the last time you did that many fractions?
Last year.
It's been a while now. It's been a while. You don't always get the chance. All right, you guys can use the rest of class to work on that assignment. Workbook. WB. WB used to be a TV station. Is it still? I think Warner Brothers.
Oh, like the biggest thing on there. Franchise.
But like Sister was on there. Anybody heard of Sister?
Yeah.
Yeah, it's on Netflix now. That used to be on the WB. Tiny Toons. So good. I don't know if that was the WB. Dawson's Creek.
There's like no room.
Yeah, there's no room to do all your replacement sets, all your possible solutions. You have to do this on another piece of paper. Man, I think there's a lot of work to do.
What time is it? We're not changing the page.
Yeah, what time is it?
9:10.
You guys did so well in class today that I'm going to make this shorter.
Just make it 6 minutes.
Yeah, I'm going to change this, you guys. I'm going to cut this assignment almost in half. Watch this. I'm going to take away the page 10. And I'm going to make page 9 1 through 7 because number 7 is a fraction. Okay, so I took away 6 problems and I added a fraction. I took away a whole page. And I added a fraction. So I'm really good about that. So, can you change your assignment sheet? Is that so annoying when I do that? It is. It is so annoying when I change the assignment. I just love to have the flexibility to make choices in the moment after I've spoken to you. We've had a moment.